All right, so today's really just meant to be, I don't have anything kind of pre-prepared. It's just a time for people to ask questions. So there's only one, you're the only person here, and there's only 2 people on Zoom. So if you guys have questions, I'll go cover, even if it's just a general question about like, I don't know, when do we multiply the p-value by 2 to get the correct p-value, or something like, something kind of, it doesn't have to be super specific. So I'll open that. Actually, before I open it up, there is one thing I do want to show, just because you're here. Also, I'll be putting this up on YouTube, so if people have questions on this will hopefully answer it. So this morning, I finalized, so you can see all your old online quizzes, your Excel, Connect, and Learn Smart grades. So I have kind of dropped the lowest for everybody, right? And so I've got your grade in kind of each category here, and that's what's kind of being counted towards your grade with the lowest dropped, okay? So you can use these as well as kind of your first 2 exam grades, which you can find up here. Right? If you then go, and I've showed you this before, but those are the grades you can now use in this figure out your grade tool, right? Kind of use those where it's already got the lowest dropped, right? So those are up all up on Canvas now. If you have any questions over those, let me know. So the only thing left really should be that final exam, okay? So once you finish it, it won't update your grade. It'll just be kind of sitting there. Once the final exam is closed, I will then kind of go on my grade book, get your lowest, middle, and highest, weight them accordingly. And that should be done sometime on Thursday, right? I have to grade them. So it'll probably be sometime I'm hoping to get through a lot of them on Thursday. So Friday, you should start to see kind of your final grade. If you're curious, you're on the cutoff. If you want to send me an email, I can email you back about kind of where your grade is, because like I said, I'll have to be grade all the finals and then kind of drop the lowest and those, so they might not be posted until Friday or Saturday. But if you're really curious, if I've got yours graded, I will kind of get you an email response pretty quick to kind of let you know how things played out. All right, that should cover it. So I've got kind of the formula sheet, our practice exams. Another thing that I put up on Canvas that might be a good study tool is this 5th Excel homework. So you can kind of see my work in the Excel file. I kind of have the interpretations there. So if you missed any points or you just didn't do that, which is fine, it'd still be a good study tool. Okay. All right. So are there any specific questions that anybody has? I can kind of start out with those.
I have a question just about the last Excel assignment.
Yep.
So the standard error whenever you did the output was just so high. So I was a little concerned about that. Is that like normal? Like, be high?
Yeah, so we look at this. Right? So you're thinking about looking at these?
Yeah, and yeah.
Okay.
A lot of them were really high, so I didn't know.
So the standard error, right, this is a good kind of review. Oh, I did not mean to do that. So this is a good review. We don't really use the standard error for much. We do use it to calculate our test statistic. So one thing to kind of remember in here, it didn't make you calculate the test statistic. Excel did it for us. But if we wanted to, I could actually calculate these by hand, because all the test statistic is the coefficient over the standard error. So I'm kind of reminded of that in my formula sheet, right? If I can't really remember this, honestly, I could just type this out in words and say, right, it's my coefficient divided by my standard error. It's as simple as that test statistic is. So if I'm here, I could just take that coefficient, divide it by the standard error, and I could reproduce my test statistics. Now, in terms of how large those standard errors are, it really depends on the size of the coefficient, right? If my coefficient is 20,000, a standard error of 15,000 really isn't that large, right? It kind of depends on what that coefficient estimate is. Kind of depends on the units of whatever variables that you're looking at. But yeah, this was kind of a unique way, right? This is an actual data set. So the one that I give you on the exam will probably be hypothetical, so that I have p-values a little more interesting. Because here, notice, when I've got test statistics that are pretty large, right? When we say pretty large, really, remember, these test statistics still represent the number of standard deviations away from the assumed true value. Where our assumed true value, I'm going to switch over to the .cam here real quick, so you can have these written out. There we go. So remember, the assumed true value for all these slope coefficients is 0. All right, so we're seeing something that's 4, 5, 6 standard deviations away. That's pretty far, right? Really, the only ones that start to get interesting is if we're like 1 or 2 standard deviations away, and see here, all of our test statistics are pretty large. So that's pretty uncommon, but brings up another good point, which is that once we find the p-value, or once Excel finds it for us, which of these can we reject? So I saw a lot of people, if they looked at this, they said you only reject the null hypothesis, right? And what's that? Yeah, give me 1 second. And what's that null hypothesis? Waiting for the screen in class to catch up here. Okay. So what's that null hypothesis? Is that there's no relationship between that x and y variable, right? That slope coefficient is 0. Well, if I can find a p-value, just like every other hypothesis test, when do we reject? When the p-value is less than alpha. So a lot of people on the Excel kind of flip this. I don't know why. It's still the same if the p-value is less than alpha. So they were like, oh yeah, 0.002, that's definitely going to be less than the alpha of, I think I gave was 0.01 or 0.05. So I can reject the null, whereas if I'm rejecting the null for these slope coefficients, it's another way of kind of saying, I found that there's a significant relationship, at least at that level, right? The 1, 5, or 10% level. Now, the problem is it's not just the male variable, because all of these variables, right? I need to navigate this. Okay. All of these variables as well have p-values where if it's e to the -7, that means move this decimal 7 places left. All these are pretty much 0 as well. So I actually would reject the null for all of them and say that they all have a significant relationship with my y variable, which I believe was birth weights. Okay. Does that kind of help clarify? Yeah, okay.
That makes sense.
Okay. I went over a lot more than just the standard errors there, but it was a kind of a good lane to open up that discussion.
Yeah.
Any other kind of questions, general questions that anybody had? Or even on specific problems, or no, you just showed up. So let me think. So things that we've went over that we could go over something different. So I'll use the last section because there's a couple good questions there to go through some stuff for you guys. So we covered a little bit of this already, kind of that discussion there. But a couple good things to be able to know how to do specifically for that short answer portion. I'll kind of go through these slowly since I already have everything written out. So, we've usually got some Excel output that looks something like this, right? This is going to be the setup for a short answer portion. I can tell you, and I'm not saying these are the exact questions you get, but, I'll have some multiple choice, and then one of the short answers will be linear regression. And the things to kind of, I think, feel comfortable with or know how to do going into this exam, not just for the short answer, but for the multiple choice questions as well, is if I'm given this output, I need to know how to be able to interpret slope coefficients and intercept coefficients. So I saw a lot of issues with this on the fifth Excel. So I'm going to go through kind of walking you through the general and then kind of how we do this. So notice I've got my 2 slope coefficients I asked you about interpreted here, and then also an intercept. So I'm going to just write out what the general form of the interpretation would be. So if I'm looking at a slope coefficient, right, the interpretation is always going to be a 1-unit increase in x, I don't know why I put a comma, is correlated with a coefficient value increase or decrease in the y variable. Right? So it sounds a little bit weird because I could put like beta here, but it's really going to be whatever that value is. So if I'm looking at like the length of the pregnancy variable, right? I would not say, so this is a common mistake up. I would not say a 1-unit increase in length of pregnancy. right? I mean, that is not completely incorrect, but right, if you know the units, which I'm telling you here, 1 unit is like the general interpretation. So a 1 week longer, right, or 1 unit increase in the length of the pregnancy is correlated with a 111.9, right, the value of the coefficient, and it's an increase in our y variable is birth weights, so in birth weight. And also here, we really should, what's 111 what? Well, our birth weight, if we go back to the original data, is measured in grams, so 111.9 gram increase in birth weight. Right? So you're kind of making this in general form of the interpretation, but write out whatever the units are for your x and y variable. Okay, and you need to write those out. Don't simply state a 1 unit. Also, don't do this. So one common mistake I saw here was interpret the slope coefficient, and someone would just go 111.9. Well, no, that's the value of the coefficient. I'm asking you to use that value to make this interpretation of what the relationship is between our x and our y variable. Okay? Now, for variables like male here, right, which I didn't ask you about, but some people interpreted for some reason. If I'm thinking about the general form of this interpretation, a 1 unit increase is going from a female, right, looking at a female, which was a 0 category, to the category that's 1, which is male. So a male child is correlated with a 97 gram increase in birth weights relative to whatever the 0 group was, which was female, right? So that 1 unit increase is kind of like going from the 0 to 1, comparing a male to the female, right? The 1 group to the 0 group. Now, one thing I left off of these is what? If I've got multiple variables here, right? One thing that I need to add on to at the end of these interpretations is that I am holding all else constant, right? Or I could write it out, right? I could write out every single variable, right? So I'll add this to the general, holding all else constant. Or I could even be really specific, right? So I'm looking at that male variable. I could say, instead of holding all else constant, holding constant whether the birth was premature, the length of the pregnancy, and I forget the other variable that we include. Oh, and mother's smoking behaviors, right, while pregnant. So just list out, basically, all the other variables that were there. But I can simply say, and for the exam, I'll count as, all you have to say is holding all else constant there, right? So that kind of makes it a little bit easier. But if you wanted to write it all out, you can. Now for the intercept, I want you to be able to see this. So I'm just going to insert a couple column or rows here so we can see what I'm doing. For the intercept coefficient, that's another one you should be able to interpret, right? It's simply if all x variables are equal to 0, and I saw a lot of people make the mistake of saying like all else constant. No, it's if all the x variables are equal to 0, then the predicted y value is whatever that intercept coefficient is. So for us, right, I could just say if all x variables in our regression are equal to 0, the predicted value of birth weight is what? Negative 1,007 grams. Let me move this over here so we can see all this. Now, that seems really weird, but it's because, like, if we actually were to write this out, it would be not just if all variables are 0, but if it's not a premature birth, the mother doesn't smoke while pregnant, the length of the pregnancy is 0 weeks, and the child is female, the predicted birth weight is negative 107. Well, you can't see a negative 1,000. You can't see negative grams, for birth weight. That's because this hypothetical scenario where all these are 0 just we never see that, right? We never see the length of a pregnancy where a child is actually born be 0, right? And so it'll often have kind of a goofy kind of interpretation, but that's still how we interpret it, okay? Any questions on that before we keep moving through these? Or if you have other questions that you'd rather kind of see me work through. So the other one, I know I mentioned some of this last week, but I'll skip to 4 because we really kind of already said this, right? Which was making rejection decisions, which we said it's the same as always. We only reject if that p-value is less than alpha, right? So we only reject if that p-value is less than alpha. And what are we rejecting? We're rejecting that there's no relationship. So if we reject, what we're really saying is that there's a significant relationship between that x and y variable, okay? Now, step 3 here, calculating your test statistic. I kind of already mentioned this one as well, but these should be the easiest points in the exam. And if I ask you for a test statistic, all you're going to do is go to that variable in your regression output, take the coefficient, divide it by the standard error, that gives you your test statistic, okay? So the other ones I would look at, and I kind of already kind of had here, right? If we reject, that implies that there is a significant relationship, because what we're rejecting is that the relationship is 0, right? And we use that same rejection decision. The other thing that you should be able to know how to do is make predictions for y, okay? So, you know, there's a good example of that in that Excel answer key. If we go to question 2, right? What I did here was, zoom in, right? How do I make predictions, right? If I look at this formula sheet, it kind of reminds me, oh yeah, if I want to predict y, I'm just going to take my intercept and my slope coefficient values, right? I'm going to take these values and plug them in to this equation. I'm then going to take this hypothetical scenario, whatever the x values are for these variables, and make a prediction for this person, right? So for instance, in that Excel file, I think I said, you know, for someone who's, you know, a child that's not premature, the mother smokes while pregnant, it lasted 38 weeks, it was female, married, twins, mother's age was 25, the weight gained was 30 pounds, what would the predicted wage be? Or predicted wage, sorry, that's a different example. Predicted birth weight be, okay? Well, all I'm gonna do is take these coefficient values, plug them in here, then take those hypothetical x values, plug them in, and now it's just like a simple like linear equation, right? They just kind of like this enter in my calculator. Now, a couple mistakes that I saw people make was, for one, and you don't have to do this in Excel, you can easily do this by hand, you have to add in the intercept, right? If you're making a prediction for that y value, you need to add in the intercept. For the other ones, another mistake I saw is read the question carefully, and if I'm telling you it's not a premature birth, and this premature variable is just a 1 or a 0, right? If we look at kind of the original data, it's just a 1 or a 0, right? Then if it's not a premature, oops, sorry, wrong sheet. If it's not a premature birth, then it would be this coefficient times 0. Well, anything times 0 should be 0, so I really don't have to add it in. So one thing I saw a lot of people do was, for all these indicator variables, they just added all the coefficients in, no matter whether or not that variable, x variable, would take on a 1 or a 0, right? So even if there is a coefficient on the variable, if it's a 0 x value, right, this birth was female, 0 times 95, you should have been adding in 0 to your prediction, okay? So that's one mistake I saw. I think that, oh, and then I already mentioned kind of the intercept, right? So the other thing you could be asked to do is, like, let's say, this doesn't apply to our example. So you can look at the effect of more than one unit, right? So let's say I want to know the effect of being kind of 10 years older, right, on birth weights, okay? Well, if I looked at that regression output, all of these coefficients tell me the effect of 1 unit, right? So if I look at that mother's age, the effect of being 1 year older, well, it increases birth weights by about 10.8 grams. Right? So if I want the effect of, what did I say, being 10 years older, I would take the effect of 1 year and just multiply it by 10, right? And I'm done. So one thing I saw people do is when I asked about the effect of more than 1 unit, they were treating it like it's a prediction, right? No, we simply want to know the effect of being 10 years older. So it's not a prediction. So what you don't need to do is here, you're not adding the intercept in. You're only adding that intercept in when you're making a prediction for y and you have values for every x variable, okay? So that should be kind of, I think that's kind of a good thing to go through, all the linear regression stuff. The other thing that I would say, make sure you know how to do, is just know the interpretation of r squared, right? So all r squared is as the proportion of the variation in our y variable that we're explaining with our x variables, right? So for instance, in that birth weight one, it'd be the proportion of the variation in birth weights that we're explaining with, you know, whether the mother smokes while pregnant, mother's age, you know, all those variables that we include in our regression, right? So if we look at that, our r squared is up here. We're explaining a proportion of the variation in our y variable of about 0.45 or 45%, which means that 55% is left unexplained, right? So when we're making predictions, we're missing about half of the important things that matter, right? So we would like to probably go out and gather more information on these people to try to get this r squared higher. But notice if we go to the first regression in that homework, we only included 4 of those variables. And there we're only explaining about 37%, right? Or a proportion of 0.37 of the variation in birth weights. So then when we added more in, well, that kind of makes sense that when we add in more variables, especially ones that you would think matter like weight gain and mother's age, we get a higher r squared, right? So knowing that kind of definition of r squared would be good for studying when you're, or sorry, as you're studying for the exam. Okay. All right, so I'll stop here. Are there any questions that anybody has, or things that you would want to see me kind of work through?
Yeah, would we be able to go through a couple examples to like solve for p-values and just kind of that general area?
Yeah, so I'll actually walk through so we can see the differences in calculating p-values for some different scenarios. So we can use some values here. I'll probably just make them up. So we won't actually be like calculating test statistics since you're more concerned with the p-values, which I think is important. Just as kind of a reminder, right? We've got 3 types of tests, right? We've got, so I'll just look at the alternative hypothesis, right? The null would just be the opposite. But we're looking at these differences, right? Whether it's a difference in sample proportion or a difference in sample means. We have greater than 0, less than 0, and not equal to 0, what we've been doing. Right? So we've got a right tail test, a less than sign, so a left tail test, a not equals to sign. We've got a 2-tail test. So these were both kind of our 1-tail tests, right? So let's say I calculate my test statistic, right? And I want to find my p-value. So let's say I've got a right tail test, and here's my test statistic, right? I don't know, let's say this is 2.25. Okay. The p-value is the probability I see my test statistic or anything more extreme or larger in absolute value. So for a right tail test, the area to the right of my test statistic gives me my p-value. So how would I look this up? Well, it depends, right? I need to know what type of example am I looking at. If I'm looking at proportions or a situation where I've got I know my standard deviations or my population standard deviations or population variances, I'd be dealing with that standard normal. If it's not, I'm looking at a student T. And we'll go over the kind of, well, actually I can probably do it to the side here. All right, so the only time we use that standard normal is if I'm looking for the difference in proportions. So anytime I see proportions, think standard normal. Or I've got the difference in means, but I know the population variances, okay? So these are the 2 scenarios I can use the standard normal. The student T, I use that if I've only got sample variances and I want the difference in sample means, or I'm looking at these kind of matched pairs examples, okay? So let's say I had a scenario where I was looking at difference in proportions. So I'm dealing with that standard normal. I've got my test statistic. I go to the, oh, actually, I think I forgot to open that up. I've got the student t-table, but not this one. There we go. So I've got my standard normal table. My test statistic is 2.25. So I scroll down here. Here's my 0.05. So 2.25, 0.9878. But remember, the table always gives me the area to the left. I already forgot. Was it 9878? Yep. So 9878. So for a right-tailed test, if I want to find the p-value, remember that's the area to the right, so I'd have to do 1 minus that. Okay? Now, if this was a student t-distribution, I would have to give you an assumed true test statistic that was different. So for one, first, if I've got this scenario, this was a scenario where I told you I'm going to give you this assumed degrees of freedom because this is this really complicated formula, right? So let's just say I gave you an assumed true degrees of freedom of 50, right? Or if it was a matched pairs, right, or this average difference, you'd have to calculate your degrees of freedom, but it's simply n minus 1, right? But we'll use like this scenario where I'm giving you the assumed true degrees of freedom of 50. So I go to my student t-table now. I've got a different type of problem. I go to degrees of freedom of 50. The problem is 2.25 isn't on this table. I would not give you an example where the test statistic was 2.25 and you have to use the student t-distribution because I said, well, there would be in between two. I could put a range on it, or if I used Excel, I could tell you the exact value. So I don't know. I don't want any confusion to come up with these ranges and kind of how we use this table. So if this was an example where I was asking you to find a p-value, instead of 2.25, I would have given you an example that had a test statistic of 2.009, in which case you know the area to the right there would be 0.025. Right? So you could look it up for either type of example using this we're doing a right-tailed test there. Any questions over anything I said there? I know I kind of had a mouthful. Does that make sense? Okay. So that was a right-tailed test, finding the p-value. So I won't go through all the steps again, but it would be very similar if I was doing a left-tailed test. Right? For a left-tailed test, I'd have this negative test statistic, evidence on the left side that goes against the null. So there, my p-value is going to be the area to the left. Well, this is a lot easier. Like if I had a test statistic of negative 2.25 there, but when I look this up in the table, it gives me the area to the left. I'm done, right? So that one's a little bit easier for a left-tailed test. The other one that's probably is a little bit more complicated, and this is one I think a lot of people get tripped up on. So let's say I had the same test statistic as I did before with that right-tailed test. So I'm thinking, okay, probably I saw that test statistic or anything above it, right, or more extreme, right? And I say more extreme because for right-tailed test, a larger positive value, negative, it's a larger negative, so it's actually less. So more extreme or larger in absolute value. I'm like, okay, this is my p-value, but it's not, right? Because for a two-tailed test, it would have been equally as likely for me to see something that far away from the assumed true difference, but below it, right? So I've really got two tails, and when I add those tails together, that's my p-value. So I can find the area in this right tail. It'd be very similar to what we did before, right? I looked up the area to the left. It was what? 0.9878. So I'd subtract that from 1. I get what? 0.0122. That's the area in this tail, but I know I've got two tails, so I need to then multiply it by 2, and that will give me my p-value. So for a two-tailed test, I still find the area in the tail. I just have to remember, okay, I then multiply it by 2. Okay? Excuse me. questions on that? Or did that answer your kind of question, or give you a pretty good coverage of p-values there? I'll assume it did. Yeah.
Yeah, sorry, my
Okay,
mic
no, you're
is
okay.
not working. Yeah, it's working.
You're fine. You're probably writing stuff down, and probably, you're good. So the other thing that I would say along with that, that I'll go over kind of quickly, but I think it's a good thing that some people are getting tripped up by, is when I've got these, and I think maybe just writing it out this way will help. When I've got, it doesn't matter if I'm using a standard normal or a student t here. So for a right tail test, both these distributions are centered around 0. So when I have a right tail test, when I'm looking up critical values, it's the critical value that gives me alpha in the tail, in the right tail. So it's always going to be positive. If I've got a left tail test, it's a very similar, right? It's centered around 0. So for a left tail test, my critical values will be either the z or t value that gives me alpha total in the left tail. So they're always going to be negative, right? So this was kind of my right tail. Here's my left tail test. For a two-tail test, it throws a little bit of a wrinkle. Doesn't matter if we've got a z or a t distribution, because I need there to be an area of alpha total in my tails. So the area in my tails needs to be alpha. So I'm actually going to have two critical values for this two-tail test. One's going to be positive, one's going to be negative, but it'll be the value that gives me alpha over 2 in each of these tails. Okay? So I need to remember, for a two-tail test, I'm dividing alpha by 2 to find those critical values. So another way to think about this is, right, something like that. Right? So positive for right tail, negative for left tail, pairs that have alpha over 2 in each tail for a two-tail test. And these were for critical values. Okay? Any other questions? Let me see what I went through in the last class to see if I think we actually went through more than they did already. Yeah, any other general questions there? Or?
I mean, I wouldn't mind just like one hypothesis testing problem to be worked through, but other than that, I think that would be it, just to cover the bases.
Yeah, so let me think of one that would be good. I'll actually let's just make one up here. See if I can do that. I'll probably choose numbers that don't make sense, but we'll see if I can do this off the top of my head. So one that I think would be good to work through, and it keeps the test statistic kind of simple, just so I can get some numbers here, but it gets us, we can go through the whole process. But I also think it helps point something else out. So let's say I have this sample difference, right? And I don't know, I find that it's 5. I also find that the variance for this difference is, let me think, I'm going to do 5, so do 100. Okay. And let's say our sample size is 25. Okay. So I've got this, and I want to do a hypothesis test, and maybe I want to say, I want to test for, is the average difference I think what I want to do here, I won't do a two-tailed test because I think I want to, let's say, is the average difference negative, right? Or has the, have things changed such that this, whatever the setup would be, has gone down, right? So what we want to test for is whether or not this difference, the true difference, is less than 0, right, or negative, which means we'll assume that it's greater than or equal to. So we've got a left-tailed test, and I did this for a reason. We'll kind of see why. So we've got all this set up, right? The very first thing we could do is calculate our test statistic, right? If we go to that formula sheet, some of these other ones are a little bit more complex of formulas, but we still have test statistic equations here, and then here's our matched pairs example, right? So this one's a little bit easier in terms of the computation of the test statistic, but I think there's something that we haven't done with these that you could see on the exam, so I want you to be prepared for it. So all I'm going to do is use this equation, plug in my average difference, my variance, and my sample size. Right? So my test statistic is what? 5 over the square root of 100 over 25. Now remember, this represents the standard deviation. Actually, I guess I'm going to be correct with my notation. The standard deviation of the difference. So the sign of my test statistic will always tell me the sign the sign of the difference will always tell me the sign of the test statistic. I'm actually going to change something here because I wasn't thinking. So instead of 5, let's do -5. I want this to be a negative test statistic, okay? So I compute this, I plug this in my calculator. This is going to be what? If I'm doing math in my head, so 4, 2, I think this is -2.5, right? So I've got a student t distribution, right? My test statistic is -2.5, okay? So if I've got a left-tailed test, my p-value is the area to the left of that test statistic, okay? So this is going to be one where I can't find the exact p-value unless I use Excel, because if I go to the student t table, well, first of all, what's my degrees of freedom? Right? Well, my sample size was 25, right? So my degrees of freedom should simply be, for a matched pairs example, this is where I won't give you the assumed true degrees of freedom. You have to calculate it because it goes back to being simply n minus 1, right? So I've got a degrees of freedom of 24. So I'm going to scroll up here. The problem is I don't have 2.5. Oh, I was one off. I knew there was one of these. Okay. Well, we'll act like I chose the right one. So notice at this degrees of freedom of 24, my test statistic of -2.5, I can't find it. This one's pretty close, right? So we'll act like I chose numbers that gave us 2.492. I was thinking this was the earlier one and I would have had it exact, but we'll use what the actual numbers I got. So technically, you know, if I did find -2.49, these are all positive values. But remember, it's a symmetric distribution. So if I think about it, my degrees of freedom of 24, 2.492. If I go up here, the area to the right of 2.492 is 0.01. So the area to the left of -2.492 would be 0.01 as well, right? It's a symmetric distribution. So with a left-tailed test, if I'm using the student t-distribution, it's a little tricky because I can't find my test statistic here, right? These are all positive values. But what I can do is I can just find the positive value and remember, oh yeah, it's a symmetric distribution, so it'll be the same area to the left of the negative value. So the area to the left of -2.492 would be 0.01. Now, I don't have -2.492, right? I have a slightly different value, which is why I said on the exam, if I was doing this, I would have given you something that worked out to be exactly 2.492, right? So we can say like the p-value is going to be, right, it's going to be really close to 0.01, but it's going to be a little bit less than that, right? Just slightly less because the area to the left of -2.492 was 0.01, so the area to the left of this will be just a little bit smaller. So if I'm thinking about my rejection decisions here, well, that's actually good because I know my p-value is just barely below 0.01. So when do I reject? I only reject if my p-value is less than alpha. Let me get rid of this here. Well, if I've got a p-value that's less than 0.01, well, that's going to be less than 0.1, less than 0.05, and it's less than 0.01, so I can reject it all. Right? So it's a little bit tricky, right? We have to remember we can still find my degrees of freedom for these matched pairs. It's a little tricky with that left-tailed test because I have to think about it's a symmetric distribution, and I would have to give you exactly one of those values. I was a little off. I should have looked ahead of time because I couldn't remember. If I would have chose a sample size a little bit lower, we would have been okay. Now, if I wanted to look up critical values, this is another one that's a little bit difficult if I'm using the student t-distribution, right? So let's say I have a left-tailed test and I want to find critical values. We said earlier, right, our degrees of freedom was 24. But I need the three values, right? The critical value that gives me 0.1, critical value that gives me 0.05, and the critical value that gives me 0.01 in the tail there. Okay. So what I can do is go to my student t table at degrees of freedom of 24. See if I can get this on one line here. Just barely. So the area I wanted in the tail was 0.1, 0.05, and 0.01. So I can go to those three columns at my degrees of freedom 24, 1.318, 1.711, 2.492. The problem is, right, if I answer those as my critical values, I'll be wrong because I've got a left-tailed test. So it's going to be those same values, but negative. What was the last one? Negative 2.492. Okay. So it's going to be those same three values, but for that left-tailed test, they'll be negative. I could think about now I've got my rejection region. And now if I'm plotting my test statistic of negative 2.5, it's just barely in that rejection region, and so it's in all three of them, right? So I'd end up similar to the critical value approach, rejecting in all three, okay? Now, so using that student t-table is a little bit more difficult with that left-tailed test. I don't think we went through an example of that, so that's why I chose to do that. Any other last-minute questions or something else? We've got what? We got 7 minutes left if we have any questions to go through. No? Okay, so one thing I will mention, so yeah, I think it's good that we kind of went through just a quick synopsis of how we do 1- and 2-tailed p-values and critical values. I would really pay attention to the discussion that we had about those 6 things that you should know for linear regression, right? So we walked through these 4 and these 2. Oh, actually 7, because I also added in that you should make sure you know the definition of the R squared as well. So those will be good things to review. I think going through those practice exams, those are going to be good practice for the difference when you're looking for hypothesis testing for like the difference in means, matched pairs, difference in proportions. So those first few problems in both practice exams will be good to work through. The questions on the linear regression, it's good, like they're good additional examples. But remember when we worked through these last week and I kind of added in additional questions, it might be good to go back and look through that. Also, last Monday, we went through, when we went through those 2 different Excel data sets and we kind of did some, and I added in a bunch of questions for each one of those. That might be a good thing to review if you're wanting some more linear regression practice. And then also some more linear regression practice, a good thing to do is to go through that answer key for the 5th Excel, right? Whether you did it or you didn't, because I was a little bit lenient on the grading. If you want to see kind of a really detailed answer or kind of, worked out or, correctly and having kind of like real, I guess, precise interpretations, I would kind of look at that Excel answer key as well as kind of a good blueprint for how you were going to approach the linear regression questions on the exam. Any other questions for me? The only other thing that I would ask, and I know there's not a lot of you here, so it's maybe some of you have already done it, so I might be, I might be telling something you've already done. I know you get spammed a bunch with emails. I do too, and I did post an announcement. But if you don't mind today, if you've got a little bit of time before the end of the day, get on and fill out those student evaluations. Actually, I think they might have to be turned in before 5, so sometime this afternoon. It really helps me out a lot, and it helps the college out if you don't mind doing that. Even if it's, you've got a couple things that maybe you think I could do a little better. Look, this is my, 2nd semester being prepared to teach a hybrid course. I by no means think that I am an expert at it. So any recommendations that you kind of have in terms of some of the stuff that was done online would be beneficial. Who knows where we'll be next year, hopefully back in the classroom, but we will see, right? So other than that, if you have a question as you're taking the exam or kind of preparing for the exam over the next couple of days, I'll be keeping an eye on my email. I'll try to get you a response as quick as possible. Other than that, good luck with everything you're studying, and have a great summer. And yeah, we'll see you next fall for some, hopefully most of you.